that we were discussing the von Neumann architecture. I discussed with you that in the earliest of the times, starting from 1943, we used to have bigger machines, bigger computers that consist of whole auditoriums, and you might not be able to work with all of the computer functions at the same time. So it was in 1945 that John von Neumann, an American scientist and researcher, proposed this system that that the computer system should be consisting of these stages. That is included in your John von Neumann architecture. The model proposed that instructions to be stored alongside with the data. That means that you have the compatibility to multitask, multifunction at the same time. That means that at the same time you have the function of stored programs concepts as well. Stored program concepts means that now the computer that stores instruction into some sort of digital memory. Digital memory means either RAM, ROM, hard disk drive, solid state drive. Programs are stored on any secondary devices. Secondary devices means some memory. Modern stored program keep its instruction and data in RAM. RAM means a random access memory that is used for the execution of your tasks. Data and instructions are moved to registers for execution. That means that if you have any specific information and if you have data that you want to move from one place to another, or if you want to execute it, so it is moved to the registers. I have different types of registers that we will be discussing that. It is also possible for more than one program to be stored into the computer. That means at the same time you can store multiple programs. So you have the option to multitask, and at the same time you can store more programs into your computer. Instructions are also fetched one at the time. Fetch means that you are receiving those instructions or applications. So this was basically the structure of the John von Neumann. He gave this idea of stored program concepts. And stored program concept means that you are using a digital memory, you are using a secondary memory, you are using a stored program computer for working out with your RAM, ROM, you are working for your execution like this. Now, the John von Neumann model consists of these areas, right? Like first of all, it says that you should must be having a CPU. A CPU stands for Central Processing Unit. At the same time, it should must be having a storage as well. Now, when it comes to storages, you have one, two, three, four types of the storages, and all of them has different functions and functionalities. Like the first one is the secondary storage. The secondary storage means your hard disk drive, your solid state drive, the storage devices that are used for you to store the data. This one, this is your secondary storage, like right, like I have hard disk drive, I have solid state drive. The second part is the primary memory, which is considered as a RAM and ROM. We will discuss this quite in detail, but for now, RAM is considered as a random access memory. ROM is considered as a read-only memory. So whenever you are processing your tasks, all of your data is stored in RAM. However, if your computer is turned off, or if suddenly the power goes off, so your computer starts from the resting state, like right, like for example, if you are taking a class right here and suddenly your computer is turned off, so when you are going to open that computer, your class is not going to be resumed. That means you again need to open the Zoom. So right now, if you are taking a class, so that means that the execution of the software that is helping you to take the class is currently stored in RAM. RAM is random access memory, and ROM is read-only memory. In ROM, your basic instructions of the computer is it's stored. That means that the how the computer is running. So ROM is a permanent memory. You cannot change it. It remains same. RAM is a temporary memory. It stores the execution of the programs. So von Neumann architecture gave you this idea that you should must be having a central processing unit. Along with a central processing unit, you will should be having something to work on in terms of storage. You should be having a secondary storage. You should be having a primary memory such as RAM and ROM, and the third part is your cache memory. Now, in terms of cache memory is again a temporary memory that stores your interest such as cookies or history. So cache memories are usually used to load up your program faster. That means that they already know that what your choices are. Then the fourth point is basically the registers, and we will discuss the registers in detail. Registers are used for the execution, right? Registers are like some stages, like I have 5 to 6 stages or 5 to 6 registers that are used to execute your instructions one at a time. Then the last part is the input and output device, which is also very important. So the reason is that why a computer uses input devices. The answer is that because if you want to add the data, if you want to give instructions to the computer system, so you use an input device, such as you have a microphone, you have a keyboard, you have a mouse, all of them are input devices. However, if you discuss in terms of an output device, so output device basically means that these are the devices that are used to generate output, that are used to generate the results. So for example, if you are working with the help of a keyboard and mouse on the screen, and their result or their output is being generated, so that is an output device. But the way that you are giving instructions is with the help of input. So till now, do you have any problems with the basic idea of von Neumann architecture?
No, sir.
Perfect. Okay, so now we are moving on to the role of the CPU, right? Like our syllabus says that we need to understand the role of a central processing unit in a computer. What is the role of that, or what is meant by the microprocessor? So, for example, if I ask you that what is the role of a computer system or why a computer system is used, so the CPU processes instructions and data that are input into the computer so that the result can be output. So the reason of using a CPU is to process the instructions, is to process the tasks and data that are input into the computer. So that means that your results can be generated. You need to understand that if you want to complete a process, how it really happens. First of all, you give input to your computer, then the process is completed, and then the result is generated. So what is the purpose of a CPU? The purpose of the CPU is to process those instructions and data that you are sending or you are inputting into the computer so that your results can be output. So the CPU reason that what is the reason of a central processing unit? The reason is that it processes your instruction, it receives input and it generates the result, it generates the output. So this is the first point. Then the second point is that a micro processor, which is basically a part of a CPU, is a type of integrated circuit on a single chip. And this integrated circuit is responsible for the processing, for the speed. So for example, if it is a big question into your paper that you need to understand the role of a CPU in a computer system, so you can write that the CPU processes instructions and data that are input into the computer so that the result can be output. However, if they ask you that what is a microprocessor, you can write that a microprocessor is a type of integrated circuit that is built it on a single chip, and with the help of that, you can work with your instructions. So now I'm moving on to the third category. The third category is that we need to understand the purpose of the components in a CPU that a von Neumann architecture has. So if it is a von Neumann architecture has first of all a control unit. The second unit is arithmetic logic unit. The third unit is registers. And these are all of the types of registers, and these are all of the types of stages or registers that we are going to work on to that. In a von Neumann architecture, I also have the example of buses as well, and I have three types of buses. So the three types of buses are address bus, data bus, and control bus. So as you can see in this diagram right here, this is your CPU, this one, and this is your RAM and ROM. So first of all, if I give you this example of the address bus, so you can see that the data is being transported from your CPU into your RAM. That means that the data is not sent back. It is just being sent to RAM. It is not sending back to the CPU. So what is the purpose of address bus? The purpose of address bus is that it is sending the data from CPU to RAM, and it is only one direction. One direction means that it can send data, that's it. If you have a data bus, you can see that the data is sent and the data is received as well. That means that it is working in both of the directions, from the CPU to the RAM and ROM. And then you have the control bus. Control bus is also in both the directions. You can see that the data is being sent and received as well from your CPU to RAM. Bus means a signal or a type of component into a computer system that is responsible for sending data from one place to another. Right, we are like we have an address bus. This is responsible for sending that the addresses from one place to another. Then we have a data bus. Data buses are responsible for sending the data. Then we have a control bus. Control bus is maintaining the control mechanism of your computer system. So now I'm going to discuss the very first part of the von Neumann architecture, and the first part of a von Neumann architecture is a control unit that we need to discuss. We need to discuss that what is the use of a unit, or what are the duties that it performs. So first of all, if it is a control unit, you have the first one right here, that this is the internal part of a CPU. That means that the control unit of a von Neumann architecture is the internal part of a C central processing unit. Now, what is the purpose of a control unit? The purpose of the control unit is that it is controlling the flow of data in the CPU. Controlling the flow of data means that if you are uh, working with the computer system. That means that at the same time, you are also using an input device and you are also using an output device. For example, if you are writing your assignment, so for writing your assignment, you are going to use keyboard as an input device, and the result that is going to be generated, it is going to be shown to your output screen, that is going to be the monitor. But can you just think out that, like, for example, if you are typing something into your computer system, that means that it is sending the signals to the computer system that you are using your keyboard. And similarly, you have the whole process of the computer, like the flow of signals that is being sent from one component to another with the help of your buses, as we discussed right now. So the purpose or the reason that I have a control unit in a CPU or a von Neumann architecture is that it is controlling the flow of data in a CPU. The flow of data means that you can see that this is the control unit right here. You have the commands from the input devices, you have the commands from output devices, and at the same time they are being processed as well. So there should be a supervisor, there should be a manager, there should be someone who is taking care of all of these processes, like how the all of the processes are being controlled. And this is done by your control unit. Your control unit is the one that is controlling the flow of data in a CPU. Then I have the third part. The third part says that this controls the interpretation of memory, processors, and input and output. Controls operations means if you are giving some instructions of input, your output is being generated, or your memory operations are being performed. So all of your operations is being controlled by this supervisor, this manager, which is known as a control unit. It is also used to interpret your instructions as well. So do you have any problems in control unit?
No, sir.
Then I have the third part right here, which is the arithmetic logic unit. So arithmetic logic unit is again the internal part of the central processing unit. Now, there should be a unit of your computer system in a von Neumann architecture that is responsible for addition, calculation, multiplication, subtraction, division. So this unit is basically responsible for making out all of the calculations into a computer system, right? Like less than, greater than, all of the calculation parts, which also includes that if you want to move your data, if you want to move from one place to another, if you want to calculate the file size or something, so all of the calculations are done by an arithmetic logic unit. So for the calculation of this, like there, there should be a space where all of these values are calculated. So also all of these values are calculated in your accumulator. Accumulator is the place where your calculation is performed, but with the help of an arithmetic logic unit. Now, the next area I have here is immediate access store, IES. This is also a part of your von Neumann architecture. So, in this immediate access store, this is a memory found inside a central processing unit. The reason for your IAS is that it holds the data and instructions. It also enables CPU to process data faster. So in your IAS, this is a part of a memory which is in between your backing storage. That means that I can give you the example of solid state drives, hard drives, RAM or ROM, but this is not the same. This is basically the immediate, the or you can say the middle level memory that is in between them. As you can see that this diagram right here, I have the input and output functionality here. I have the control unit, I have the backing storage, but all the data from input and output and control unit is being retrieved by immediate access store and as the backing store as well. So this is basically a part of a CPU that holds the data and instructions, and at the same time it enables the CPU to process faster. Any problem in this?
No, sir.
Then the next area I have right here is registers. So registers, what are registers? For registers, you can consider them as area for like stages. You can consider them as some stages that are used for sending the data from one place to another. So, what is the use of registers? First of all, they are internal memory located into the central processing unit. They are a part of your CPU. They hold the data and instructions, and they are used to move the data around the components of the computer system. Around the components means that if you want your data to be moved around RAM, ROM, hard disk drive, solid state drive. So how this execution or how this process is completed, that is with the help of your registers. As you can see, this is a diagram of your motherboard of your computer system. And here you can see that this is your CPU that is placed on an integrated circuit. Now, right here, you can see that this is your address bus, this is your control bus, and this is your data bus that is being attached to your RAM socket. So now you can basically plug the RAM right here. So this RAM is responsible for sending the addresses, for sending the data to your computer system that is in the form of binary. So I hope that this structure can give you a good understanding of this, like how this CPU is being placed right here in terms of an integrated chip. And then with the help of this integrated chip, it is being utilized, it is being helped with that address bus, control bus, or data bus. Okay, so now I'm done with the first of the two learning objectives. Uh, right along with the class, I'm just giving you some questions that you need to respond to me. So I'm sharing the questions in onto the group. So what you need to do is that you just need to give me the answers for that. Uh, okay, sure, sure. I'll show here. I'll show here. Just give me a moment. Okay, so now can you all share me your answers for these questions?